So our first topic in our next unit is dealing with slopes. Now, if we just scroll down on this page here, it says slope is a measure of the steepness of a line. So we're going to be dealing with the lines and finding out what slopes they are. Now, it's important to note that the slope of a line is equal to the rise divided by the run, or the rise over the run. So if you think of what rise is, that's how high the line rises, and then run is how long the line goes for. So let's start off with this first example. It says Louise is traveling in British Columbia. She knows that 7% on this sign refers to the slope or the grade of the hill. So now we're introducing this new word, grade. However, slope and grade are basically the same thing, except the grade is the slope expressed as a percent. So we will find what the slope is of a line, which will give us sometimes a decimal number, and then we will have to convert that decimal number into a percent to find the grade. So going back to this example, we can see that hill that Louise is talking about. So it says for every 100 meters of horizontal distance, the elevation increases by 7 meters. So horizontal distance, well, if we're thinking about a horizontal line, it goes this way. So when we're dealing with horizontal distance, we're talking about the distance of the line going that way. So exactly horizontal. So you'll notice on this diagram here, they labeled this side of the triangle 100 meters because that's the horizontal distance. That's an entirely horizontal line. And then the elevation, well, if something elevates, another way to say that is it rises. So when we see the word elevation, you want to think of the rise of the line. So the elevation increases by 7 meters for every 100 meters of horizontal distance. So right here, you can see they put the 7 meters there. So this question is asking, how are the grade and slope related? So first, let's write the grade as a fraction in lowest terms. Well, 7%, if we were to write that as a fraction, that would be 7 over 100. Because if you were to put this in your calculator, if you were to put 7 divided by 100 into your calculator, you would get 0.07. And if we were to convert that into a percent, that would be 7%. For question number 2, it says write the slope as a ratio and as a decimal. So remember, slope is equal to rise over run, or rise divided by run. So in this case, they told us the rise is 7 meters. So we are just going to put 7 here, and the run is 100, as they gave us right over here. So this again is the rise over the run. So if we were to convert that into a decimal, which we just did, it would equal, well, 7 divided by 100 is 0.07. So in part 3, it says, suppose the road has a rise of 8 meters and a run of 100 meters. What would the slope be? What would the grade be? So to find the slope, we always do rise over run, or rise divided by run. I'm just going to put here that this could mean divided by. So it says that our rise this time is 8, so I'm going to put an 8 up here, and our run is 100, which is why they put 100 down here. Now we could also reduce that fraction because 8 over 100 is a fraction, so what they did was they divided everything by 4. So 100 divided by 4 is 25, that's how they got 25 at the bottom, and 8 divided by 4 is 2. So they took this and they divided everything by 4 just to reduce that fraction to get that slope. So whenever we're dealing with the slope, you always want to write the fraction, the rise over run, in lowest terms. So you want to reduce it as much as you can. So now we have that the slope is 2 over 25, and if we were to put that into our calculator and put 2 divided by 25, we would get 0.08. So that's the decimal we would get. Now the grade is the slope times 100 because we want to convert this slope here into a percentage. So whenever we have a decimal, we multiply it by 100 to get the percent. So we're going to do 2 over 25 times 100, or another way you could do this is you could do 0.08 times 100 because 0.08 is the exact same thing as 2 over 25. And if we multiply that by 100, we would get 8%. So the grade is 8%. We'll put that right here. And the slope as a decimal is 0.08. So in example 1, it says Zenaida is a contract developer. She is building a set of 5 steps. Each step must have a 6-inch rise height, so here's our rise, and a 10-inch tread depth. What is the pitch of each step? And if you notice on the side here, it just says pitch is another term for slope. So what is the slope of each step? How does this compare to the pitch of the staircase? So each step versus the entire staircase. And is the pitch of the staircase constant? Meaning, does it ever change? So let's try to break down this question. I'm just going to scroll here. So in the solution part A, it says, what is the pitch of each step? In other words, what is the slope of each step? So we are going to use that rise over run that we discussed in the previous example. So the rise this time they give us right up here is 6. And then it says it has a 10-inch tread depth. So when we're dealing with tread depth, this here, the tread of a stair is where you step on. That's the tread. So the depth of it would be like the length of it. So that there would be that horizontal distance or the run. So in this case, the run is the exact same as the tread depth. So I'm just going to put that that's the run. And it is 10. So our slope is 6 over 10. And if we reduce that fraction, we would get 3 over 5. So we reduce it by dividing both by 2. So that there is the slope or the pitch of the step. Now it says, what is the pitch of the staircase? So the pitch of the entire staircase, we would have to do this entire run right here and this entire rise. So if we want to find out what this entire rise is, what we would do is we would add up all of these rises for each little step. So each of these rises here is equal to 6. So what we're going to do is we're going to have to add 6 5 times, or in other words, we're going to have to do 5 times 6. And then if we're dealing with the run, we're going to do the exact same thing. So this time the run is all of this. So we need to figure out how many treads there are because remember the treads are the run. So we have this one here, we have this one we already colored in, this one, and this one. And each of those is 10. So we have 5 10s there. We have 1, 2, 3, 4, 5. So we're going to have to do 5 times 10. So if we multiply 5 by both of these numbers, 6 times 5 is 30, and 10 times 5 is 50. So 30 over 50 is the pitch of the entire staircase. And if we were to reduce that fraction, we would get 3 over 5. And we reduce it by dividing both of them by 10. So let's compare the pitch of the staircase versus the pitch of each step. So it just says the pitch of each step and the pitch of the staircase are, well, they're both 3 over 5, so therefore they are the same. And then it says the pitch of the staircase is constant. That's what we're going to put there. So because the pitch of each step is the exact same thing as the pitch of the entire staircase, we could say that it is constant. And another way to say constant is not changing, so it doesn't change. In example 2, we are now dealing with a drawing on a graph. So it says Marcia is a carpenter. She drew a plan for the roof of a house on a grid paper. What is the slope of each side of the roof? How do the slopes compare? So we want to find the slope of this line right here and also the line on the other side. So in order to find the slope, we're always dealing with rise and run. So we want to find what that rise over run is. So let's start off with the orange slope. It says, what is the slope of the left side? So left side is orange. Count the squares. So that's what we're going to do. We're going to count the squares. We're going to start at this point right here, and we're going to count the squares going up. That'll reach us to the same line that this point is on, that our other point is on. So if we count how many squares, starting at this point 4, 3, it would be 1, 2, 3, 4. So our rise in this case is 4. Then let's count the run. So the run is going horizontally. So what we're going to do here, I'm just going to erase these little dotted lines I put in. What we're going to do is we are going to start at this point that we left off at. and we are going to do the run from this point to get to our final point over here, that 10, 7. So let's see how many squares we have to jump in order to get there. So 1, 2, 3, 4, 5, 6. So this time we had to run 6 in order to get to that final point. Therefore, our rise over run is going to be 4 over 6, and if we reduce that, divide them both by 2, we would get 2 over 3. Now in part B, they want us to find the slope of the same line a different way. And there's a different way that we can use if we're given the coordinate points of the two dots on the ends of the lines. So in this case, we are given the coordinate points. So if you're given the coordinate points, you can use the formula off to the side here. So M always represents slope, by the way, for some reason. I don't know why they didn't use S. But M, our slope, is equal to y2 minus y1 over x2 minus x1. And you're probably wondering what that means. So if we look at our coordinates here, I'm just going to zoom in. Remember, every coordinate point is written as an x and a y coordinate. So both of these are an x and a y coordinate. I'm just going to use a darker pen so we can see it. So this is an x and this is a y, and this is also an x and this is also a y. So what we're going to do is we're going to call this point number 1, and we're going to call this point number 2. So we're going to label the x and y coordinates of point number 1 to be x1, y1. So we're kind of just giving the x and y values another label. And then for the second point, we're going to label them x2 and y2. So that's where the x1, y1, x2, y2 thing come from in this formula here. If you can label your points like I did on the graph there, this will be no problem for you. So let's look at B again. It says, use the coordinates. What is the slope of the left side? So again, we're dealing with that orange line. So we need to find the difference between the y coordinates. And remember, difference in math means subtraction. So if we're finding the difference between the y coordinates, that's the same thing as using the top of the formula here. They just like to lay it out weird in this book, but that's okay. So 7, if you look at our diagram up here, we labeled it as y2. So that there is our y2 value. And that's this in the formula off to the side. So now we're going to subtract y1 from that. So our y1 is 3. So we're going to do 7 minus 3, which is equal to 4. And now let's find the difference with the x coordinates. So we're going to start with x2. So that's going to be this value right here. And we labeled that as 10 on that diagram. So I'm going to put x2 as 10 and then minus x1, which is 4. So 10 minus 4 is equal to 6. So therefore, the rise over the run is the same thing as the difference between the y coordinates over the difference between the x coordinates. And that's what we just calculated right here. So that's the same as 4 over 6 or 2 over 3. So you get the exact same answer as we did in this previous part here where we just counted the squares. All right, so now we're looking at part C. It says, what is the slope of the right side? So that's the light blue side I have over here. And they want us to use the formula that we have off to the side here to figure that out. So in order to use this formula, you're going to have coordinate points. So we used the formula in part B here, but they just laid it out really confusing. So let's just do it the proper way in part C. So whenever you're given this formula to use, you want to label your points x1, y1, and x2, y2. Well, this time we're dealing with this coordinate point and this coordinate point because those two are on the ends of the blue line. So what I'm going to do is we're going to leave the one up here as x2 and y2, but I'm going to swap these coordinates to be on this point over here. So this is now our new x1, y1. So this is our point number 1. So now that we have these two coordinate points labeled, let's plug them into the formula and see what we can get. So y2, if we look up here, we have that y2 is 7. You can see there. So that's what they have written here. And then y1 is 1. So we're going to put 7 minus 1. And then we have x2 is 10, as you can see right at the very top here. So we're going to have 10. And x1 is 19, as you can see right there. So now if we do this math, we have 7 minus 1 on the top, that is 6. And then over 10 minus 19, well, that's going to leave us with a negative 9. And then if we reduce this, we can divide both of them by 3. So we can get 2 over negative 3. So that is the slope there. So let's see, how are the slopes the same and what does this show? So what I wrote down here is that both slopes have the fraction 2 over 3. So here, I'll just highlight them for you if you don't know what we're exactly looking at. We're looking at this one right here, and then this one that we just found. So you'll notice the number on the top is a 2, and the number on the bottom is a 3. So we're just going to ignore that negative sign in this one for now. So because they have the same number in the numerator and the denominator, so for the rise and the run, then that means that both lines have the same steepness. Now let's talk about how they are different and what this shows. So they are different because one of the slopes is positive 2 over 3 and the other slope is negative 2 over 3. So if one is positive and one is negative, all that means is that they are going to be slanted in different directions or in opposite directions. So as you can see here, one of them is slanted going upwards this way, and the other one is slanted going the other way or the opposite way. So that is how those slopes are different, and that's because one of them is negative and one of them is positive.